So we're now going to look at the second reaction of the alcohols, and that's the oxidation of the alcohols. So how do we oxidize? We use a reagent called potassium dichromate, and it's got to be acidified. So we say it's H plus and it's K2Cr2O7, potassium dichromate. Potassium dichromate, acidified potassium dichromate, is actually orange. When it reacts with alcohols, it turns green. So you can see if a reaction has happened because it goes from orange to green. And if it's gone green, it means it's oxidized the alcohol. So, how does it work? Well, it depends on the classification of alcohol that you start with. So let's start with a primary alcohol. A primary alcohol I'm going to start with is ethanol. So if I start with a primary alcohol, ethanol, and I oxidize it. Now, how potassium dichromate works is quite complex, so we simplify it and we show it in an equation by just a square bracket O. That is telling me that is representing potassium dichromate. I'm not going to worry about what it's doing. I'm just going to say it's just supplying oxygen atoms effectively. Now, if I heat it gently, it will give me this guy. And hopefully you'll see this is ethanol. So ethanol will go to ethanol, and it will also produce water. So you can think about it, if you like, that one of these two hydrogens go off with that oxygen to give me water. This then gives me a double bond, which is there. So it depends how you want to think about it. I mean, if you want to, you can think that these hydrogens go off with this guy here to give me the water. That then creates a double bond there, like so. So that's one way you want to think about it. So what happens is ethanol's got quite a low boiling point, and hopefully you can see, it's a small molecule, it's very distilled off. So you heat it up, and basically you evaporate the ethanol off as it's produced. If you don't do that, and you carry on, so it will carry on reacting if you let it do. So this is ethanol becoming ethanol, which is an aldehyde. If you take your ethanol and rather than just heating, rather than doing this reaction with heat, you put an excess of oxidizing agent in and you reflux, so you really heat it up, it will actually continue to oxidize. So I'm going to put another oxygen in, and it will actually give me this guy here, where I inserted this oxygen into that bond there, and so that is ethanol, and this gives me ethanoic acid, and this is a carboxylic acid. So that's perhaps a new type of organic molecule that you need to learn as well. So we'll go through all these at the end. So that's a primary alcohol. If you heat it gently and distill, you make an aldehyde. If you reflux, it will go to the carboxylic acid. So you've got to control this reaction very, very carefully. So the overall reaction, if you didn't want to go via the aldehyde, you wanted to just take your potassium dichromate, which has been acidified, and reflux it with your primary alcohol, it would go all the way to your carboxylic acid, and you'd also make water as well, remember water is made in the first stage of the reaction when you go to an aldehyde. So what's happening is I've kind of combined those two equations together to produce this one. So it's produced an aldehyde, but I haven't shown it, and the aldehyde's been oxidized again by putting the second oxygen in to give me ethanoic acid and water overall. So that's fine for primary alcohols. What about the other type of alcohols? Well, we need to think, let's look at secondary alcohols. So the simplest secondary alcohol we can do is, let's go for this boy here. So this is of course propan 2-ol. So again, he will be oxidized, so I can take potassium dichromate, which has been acidified, and I can oxidize this. And you can see that I can do that because in the previous one I said it took that hydrogen from the oxygen and that hydrogen from the carbon. They went off with this guy here to produce my water, like it did when I made the aldehyde before. But now I'm going to be left with this guy here, which is of course a ketone, and this is propanone. So a secondary alcohol will produce a ketone. Will it do anything else? Well, no, it stops there. There's only one reaction. I can't get this to make a carboxylic acid. A carboxylic acid group has got to be the end of a carbon chain. And you can see this oxygen isn't on the end of a carbon chain. He's in the middle of a carbon chain, so he can't be oxidized further onto a carboxylic acid. So it stops there. You use potassium dichromate, acidified, you reflux, and you will make yourself a ketone. Job done. So let's look briefly now at tertiary alcohols. This is a nice tertiary alcohol here. It's tertiary because I've got 3 carbons attached to the carbon with the OH group attached. What happened here? Well, the oxidizing agent took the hydrogen from the oxygen and a hydrogen from the same carbon. Is there a hydrogen on this carbon here? No, it's attached to 3 carbons. So tertiary alcohols are not oxidized. So say I heated this with potassium dichromate, what would happen? It would stay orange. So that's quite simple. If you know you've got an alcohol and you heat it out with potassium dichromate and it stays orange, you know you've got yourself a tertiary alcohol straight away. So this would stay orange, all the others would go a green colour. Okay, so let's look at the different types of equipment that we can use. This is how I could make an aldehyde if I started with a primary alcohol. So into my round bottom flask, I would put my primary alcohol and my potassium dichromate and my acid. So that would all be there and it'd be a nice orange colour. I'd heat it up. As the aldehyde, so it all gets oxidised all in here. As it heats up, so my aldehyde's formed, it goes down here. This is a reflux condenser here. So your water goes in here, out there, so it gets cooled. And so my aldehyde goes down there. That relies, of course, on the fact your aldehyde has got a lower boiling point than your alcohol. Otherwise, your alcohol will be distilled off as well. So hopefully aldehyde comes up, alcohol stays in to get oxidised, down in there, and I can collect it up. Job done, nice and easy. Let's say I now want to make the carboxylic acid instead. So I don't want to go by the aldehyde, I just want to go straight to the carboxylic acid. So I put my primary alcohol here. If I've obviously got my aldehyde, I could just bung my aldehyde in here as well, because my aldehyde would be oxidised as well. So in here I've got my aldehyde or my primary alcohol. I put my Bunsen burner in, it goes up, it gets cooled down, it drops back down again. It can't escape from here because it just goes back down there. And I've got an excess potassium dichromate in there, so it gets oxidized. It goes through those both stages. 2 oxidation stages happen, and it goes, if it's primary alcohol, it goes primary alcohol to aldehyde to carboxylic acid. If I've just put my aldehyde in there, it will go to the carboxylic acid, and that's done. This would also be the way if you've got a secondary alcohol to make yourself a ketone as well. You put your secondary alcohol in there, reflux, and it would go to a ketone. So let's just do a quick summary of that, because that was a lot to take in. So first of all, a primary alcohol, I can oxidize it to an aldehyde, and then it can be oxidized further to a carboxylic acid, like so. So a primary alcohol will go to an aldehyde and then to a carboxylic acid. I use potassium dichromate to do this, but equally if I refluxed it, it would go straight to the carboxylic acid. So for this one I'm adding +1 oxidizing, for that one I'm adding +1, for this one I'd be adding +2. The thing people forget is you make the aldehyde plus water at this stage. So if you go by that stage, you make the carboxylic acid plus water as well. For your secondary alcohol, it just goes through one stage where you add an oxygen to give you your ketone, like so, plus water, like so. And tertiary alcohols are not oxidized.